Hi, everyone. I'm really excited to be here, and I know it's kind of a part of the deal to say that you're really excited to be here, but I'm really, really excited because this is my first in-person talk since after the pandemic. It's also my first talk after I became a mom, and if you're someone with small kids or you know someone with small kids, you might have heard that these first few months after they go to daycare, well, it's just hell. I mean, it's brutal. I have never been this sick, this much in my entire life. I mean, I'm sick pretty much right now, so I'm really sorry for my voice and if I start coughing, or if I will cough the entire presentation, but that's the reason. So I'm actually very proud to be here in almost one piece and with a talk to deliver today, so let's get to it. So I want to start out with the Gauss law that says that all the complex systems that work once started out as a simple system that worked. And let's start with a simple system or simple architecture for near real-time data streaming that is actually working and it's becoming extremely popular. It was even featured in a serverless book by Jan, Peter, and Ajay, which I would encourage you to read. And it's just a simple architecture for near real-time data streaming. So you take a Kinesis data stream, you write data with your producer application or the application that produces your data. And then you connect a Lambda function to it to consume or read your data from the stream. And then you pretty much can do whatever you want. I mean, sky is the limit, right? It is pretty simple, but I will tell you a short story here and I will let you decide the rest. But first of all, who am I? Why am I here? So my name is Anahit and I'm an AWS data hero. I'm also a lead cloud software engineer in a company called Solita. And a really brief slide about Solita. So we are a digital transformation company spanning nowadays 6 countries in Europe and over 20 offices in different cities, which is kind of crazy to think because when I started out, we were like 130 people in a small town of Tampere in Finland, and it has been pretty big a transformation. But enough about me and my company, let's go to the story. So as you might have already guessed, it's going to be a story predominantly about Kinesis, but not only about it. Oh, and by the way, KDS means Kinesis data streams. I personally never remember it, so I put it on the slides just to be there. Excuse me. So I was working with a customer where we were using this simple yet powerful architecture that I showed you, and we used it for near real-time data streaming. Until one day, we realized that we are actually losing data. And we realized it not because the logs told us so. Actually, there wasn't much in the logs, not at least on the producer side. Neither did the metrics tell us much, or I would say we didn't really understand what the metrics were trying to tell us. I would just say the metrics were kind of controversial. But we suddenly started to see that our consumer Lambda was behaving oddly, really, really oddly. Like write a ticket to AWS support kind of oddly. So it all started to unfold from there. So let's go step by step and begin unpacking this and to see what's actually going on. So let's talk about the KDS or Kinesis data streams first. So if you're not familiar, Kinesis data streams is a fully managed and massively scalable service to stream data on AWS. After you write the data to the stream, it is available for you to read within milliseconds, hence the real near time. And it is stored in the stream for at least 24 hours. So you can replay it, but you can store it for up to a year, and you can replay it during that entire period of time. And this data retention and replay possibilities is one big difference to something like a PubSub system, like an SNS. And moreover, it's an append-only system, so you can write to the stream, but you cannot delete records from the stream, so you will need to wait until they expire, so at least 24 hours. And the things that make Kinesis so very powerful is, well, of course, the scalability, the fact that you don't need to manage any servers or clusters, and it does scale pretty much endlessly, and it integrates really well within the AWS infrastructure. Meaning that there is a lot of services that can either write or read from Kinesis, or some can do actually both. And of course, last but not the least, there is a lot of ways to consume the stream, so to read data from your stream. So you can attach a custom stream consumer, and then you can process your data any way that you want in near real time, and that's where the actual magic happens. They will also tell you in the documentation that Kinesis is serverless. Is it though? Well, I'm here to tell you right off the bat that in my opinion, it is not at least fully. And I know I have the serverless word in my title and all over the slides, but still just let me explain what I mean here. On the other hand, of course, our fellow hero, Ben Kehoe, has been trying to tell us since maybe year 2016 that serverless is actually like most of things in life, not binary. It's actually a spectrum. So that's a separate topic for a separate talk. But why do I say that Kinesis is not fully serverless? Well, to achieve its massive scalability, Kinesis uses a concept called shard. So the shard is the unit of parallelism in your stream. And each stream consists of one or more shards, and each shard comes with a limited throughput. So it's either 1 megabyte or 1,000 records per second that you can write to one shard. And you might think of a shard of just an ordered queue where your records go, and your stream is composed of multiple such queues where records will be ordered within that queue. And what is a record, you might ask? Well, it's just the way we write data to the stream, so it's just an object containing your actual data and some metadata. One of the most important parts in that metadata is called partition key, and is just a string that you add to every record that you write to Kinesis. Kinesis will not accept records without a partition key, so you pick a string, you write it there, and it uses it to distribute the records across shards in your stream. So it is advised that you use as random of a partition key as you can. Sorry. I jumped, then I didn't. So, number of shards in your stream define the available throughput for you, because each shard has a limited throughput, but the number of shards is virtually unlimited, so you can add as many shards as you want based on the amount of the incoming data that you have. So basically, you provision your stream based on the amount of data that you have. And that, to me, already doesn't sound too serverless. And moreover, the amount of data, of course, can change during the time. It rarely stays the same. It can go up and down during the day or maybe the month or a week, however it goes. And if that amount changes, you would need to, or if it gets high enough that it doesn't fit in your stream anymore, you will need to add more shards to the stream that you will accommodate all that incoming data. So you will need to do something called resharding. And for resharding, there are several options. You can split shards, you can merge the shards, or you can just skip the resharding altogether and you can just over-provision your stream, meaning that you can just add a huge number of shards in your stream just to accommodate all the incoming data and never to worry about that. But of course, you will have to pay for that, because in Kinesis, in addition to paying for the data that you stream, you also pay for every open shard that you have. Still not very serverless. Of course, you can implement the so-called auto-scaling. You can Google it. 5 other services are needed to make Kinesis auto-scalable. So after all that, you might be asking, why is AWS claiming that Kinesis is serverless? And of course, they have their own reasons for that, but one of them, I would say, is that I wasn't entirely honest with you, because there is nowadays this thing called capacity mode. And you can choose one of the two. The first one is the one that I told you about, this good old provisioned mode that comes with all the shards and not so serverless options. And then there is this newer option, which is called on-demand. And it promises you auto-scaling and no shard management. Of course, the shards are still going to be there underneath your stream, because that's basically just how Kinesis works. It works with the shards. But you are just not going to see them, at least not too easily, and you will actually have zero access to them. Kinesis will abstract all the shards away from you, so that's the on-demand mode. So it kind of does sound promising already from the perspective of being serverless. Sorry. But there is, of course, a caveat. So the thing is that on-demand mode can handle double the traffic you had during your previous 30 days. So this effectively means that it will just kind of, instead of scaling up and down, like I have on this imaginary possible scaling scenario, it will just scale up to twice the previous peak. So for example, you had a previous peak in your incoming traffic that would require you to have 20 shards. This means that there is going to be 40 shards in your stream at all times. You are just not going to see them, but they are going to be there. And the scaling happens in huge increments, and it doesn't really go down too easily. I mean, if you are going to have spikes every now and then, let's say every month, this means that the amount of shards in your stream will stay high all the time. So this is the reality of how it scales. And if the amount of data grows too fast, then you are going to get throttled. At this point, I might actually mention that with on-demand mode, you don't actually pay for the shards anymore. So you might think you don't really care about, do you have 40 shards there or 140 shards? Who cares? I don't pay for them. But my personal guess is that because they are still using all those shards, and because the shards are there even if you are not using them, they are reserved for you, the pricing model of the on-demand mode at the moment is such that it's probably going to cost you much, much more the on-provision mode. I mean, my personal experience is that it would cost 2-3 times the provision mode in certain situations. So it is pretty expensive. Then again, you have to consider the total cost of ownership argument, meaning that how much extra you will pay for managing the service. Then again, in my opinion, you don't have that much extra cost with the provision mode neither. So it's kind of, you need to see which option fits better for you. But all that being said, in my opinion, it's still a really good addition to the Kinesis capabilities because it's really easy to get started. I mean, if you know nothing about shards, moreover, if you don't know how much data you're going to get, you just spin up a stream and start streaming and see how things go. Because at any given moment, you can actually switch to the provision mode with that same stream. And moreover, you can actually switch back and forth twice the same day. So it's a pretty neat opportunity to just explore the data that you are getting, and when you're familiar with the data and familiar with Kinesis, you can then switch to the provision mode. But I personally am still waiting for that real auto-scaling mode that will go up and down nicely with incoming traffic and that will scale to 0 before I can call it fully serverless. Then again, in the end of the day, it's just semantics, and does anybody care? Hard to say, but I hope this gives you at least some understanding of how Kinesis works and what are the different options nowadays. But I digressed from my story quite a lot, so let's go back to the story. Let's first take a quick glance at how we can write the data to the stream and how we can read it, and why would we do that in the first place. So remember our simple application with potential issues. So how exactly does our producer get the data flowing into Kinesis? There are plenty of options to choose from, third-party tools, integrations and stuff, and maybe notable are the direct service integrations, which can write directly to streams. Things like CloudWatch Logs and Event Bridge can write directly to Kinesis. But in our story, we use a custom producer that is writing data with the most flexible way, meaning the AWS SDK. And when it comes to reading from a stream, again, there is plenty of options to choose from. Again, third-party tools, integrations, libraries, direct service integrations, one notable one that Jimmy was telling about, Event Bridge pipes, where you can now stream directly from the stream to the Event Bridge pipes. And that opens a whole new world of possibilities when it comes to Kinesis. But we kind of already know who is the protagonist of this story, so we are going to focus on Lambda. And when it comes, to Lambda, it comes with all its scalability and all its configurability and awesomeness that comes out of the box with Lambda. And it also comes with a very extensive error handling possibilities, and I will tell you about it in just a moment. And when it comes to the use cases where you would use Kinesis, well, it's an excellent candidate for any data streaming, anything revolving around data ingestion and analytics. with consuming or collecting and processing large amounts of data, that's where Kinesis is usually used. And of course, it can be any data. The sky is the limit. You choose whatever data you have. Moreover, it's been becoming increasingly popular with the event-driven architectures that Luke was talking about. It has been used for passing event between components, similarly to Event Bridge, and other systems that are, or services that are used for those purposes. But of course, it comes with its own separate set of features and limitations that you need to consider when you pick one service over the other. Finally, Kinesis is actually used under the hood in some of the services I just showed you on the previous slide. So it is a very essential service in AWS ecosystem itself. They use it a lot, and that's a good news for us users because they also develop it a lot and pay a lot of attention to the fact that it works and it functions, and that's a good news for us. Okay, so now I have been talking about this high-level stuff for long enough. Let's go to specifics. So in our story, we decided to check our entire pipeline to see what actually is happening. And there came our first not-so-nice revelation. We were losing data. And we were losing data without even knowing about it. And that was a very embarrassing moment, I must tell you. So what's happening here? Let's take a look. So there are two distinct ways of writing data to Kinesis, or rather two distinct APIs. You can either write individual records to the stream, or then you can batch up to 500 records and send the entire batch in one request with the put records API. So you basically generate an array with your records and the partition keys and just send them forward in one request. And here's a quick illustration of why would you probably use batch operations whenever it's possible. So on the left, you have 3 individual records going as 3 individual requests, and then on the right, you write the same data with 1 request. And it's pretty obvious that the amount of the overhead here is pretty big, like the HTTP request overhead. But again, obviously, the number of requests is going to be bigger if you are going to send individual requests. And this is important because if your producer is waiting for each request to finish before it sends the new one, you will end up with increased latencies when you have a lot of data that you want to send to Kinesis. So it is recommended to use batch operations whenever you can. But of course, it comes with a consideration of how real-time you want your data to be, because collecting batches and sending records in batches is usually slower than just sending individual requests or records as they come. So there are always trade-offs to consider. Also, when it comes to batching, there are things that you must know. So it comes with some more responsibilities. So what happens, first of all, when a request to Kinesis fails? And the good news here is that AWS SDK will take care of a lot of it for you, I would say most of it for you. And if a request fails because of a so-called retriable error or like 500 error, service unavailable, or even timeouts, AWS SDK by default will automatically retry the error 3 times for you, and it will use the so-called exponential backoff, which basically means that the time between consequent retries will be increasing exponentially. And this is done so that you will not overwhelm your already stressed system. You want to spread the retry attempts as uniformly as you can. So SDK does that for you. And all these parameters can and should be configured. For example, in Node.js SDK, you can do that when you create a Kinesis instance of a Kinesis service. And here you can see maximum retry attempts and retry delays and things like that. And in the bottom, there are also some timeout settings. And it's also very important to configure the timeouts, because by default, SDK will wait for 2 entire minutes before the request times out. And I mean, just like, think about it for a second. It would wait 2 minutes. I mean, we were talking about real time, not real time, counting milliseconds. And here is SDK waiting for 2 minutes before it timeouts a request and retries it. So, moreover, it actually has 2 separate timeout configurations for new sockets and for existing socket connections. So if you add those, then you add on top of them possible retries. Each of them takes 2 minutes. You might end up with a producer that waits a long, long time for something that might not even happen. So it's very important to configure the retry to be just right, not too long, not too short. All right, so there are errors. Errors are being handled by SDK. They are retried, and if all retries fail, we want to log that something bad happened. And if you are looking at logs and everything looks fine, you assume that there are no errors, right? That's a logical thing to assume. But can you guess what is wrong with this code? And that's fine if you can, because I couldn't either myself. And the thing is, I told you that AWS SDK takes care of most of the error handling for you. But there's a catch, because in case of batch operations, like we have put records here, instead of just handling the failure of entire request, you should also handle the so-called partial failures. And the thing is that batch operations are not atomic. They are not either all succeeds or all fails. It can be so that part of your batch goes through, but then part of it fails. But from the perspective of SDK, it's a successful request. You will get 200 code back. It's a success, no errors, nothing, just silence. And it's your responsibility to detect those partial failures, and it's your responsibility to take care of them. And this is actually a very common consideration in distributed systems in general. Partial failures happen, they happen very often. And if you do not have this proper error handling, you probably don't even know about them happening. And it is a very embarrassing moment, trust me. So it's better to be prepared for them to happen, because they will, with big enough volume of data and requests. All right, so when it comes to implementing the partial retries or partial failures, or any retries for that matter, it is very, very important to set the upper limit of the retries. You don't want to be retrying forever. Just like with SDK, you want to limit the number of retries that are happening. The second crucial thing is to use the proper backoff between the retry attempts. You do not want to overwhelm the stream that is already under a lot of stress. So you want to spread the retries uniformly, and just like SDK once again. And exponential backoff and jitter is considered to be one of the easiest and most effective way to spread the retries. And jitter here just means a random component that you add to that exponential backoff. In that way, you spread your retry attempts even more evenly. So you avoid these bursts of retry. And actually, SDK does exactly that. I just didn't mention the jitter part on the previous slide. But this is very effective. And if you remember anything from this talk, please let it be partial failures and retries with jitter. I mean, it's two things, but still, partial failures, retries with jitter. It will take you a very long way, because those are things that apply to many, many, many situations. And there is actually a great quote from Gregor Hopp, and he has been saying that retries have brought more distributed systems down than all the other costs combined. So we need to be really mindful of how we implement the retries, not to break the system while we try to fix it. Excuse me. Okay, but why those failures even happen? Like, why do we need to retry in the first place? Again, as I said, there are several considerations in distributed systems. We work over a network. There might be network glitches, servers might be unavailable. Maybe your request did go through, but you just didn't get the response back, and your request timed out. You never know. More often than not, there is the throttling, which basically means you just exceed one of the API limits. So in case of Kinesis, you have this 1,000 records per second. If you exceed that limit, all the other requests will be throttled. They will fail. And here comes the next revelation. Throttling in Kinesis might happen even if you are looking at the CloudWatch logs CloudWatch metrics, and the overall amount of incoming data seems pretty low compared to the throughput that you have. So again, you are well below that red line there, and you should be just fine with this stream. You shouldn't get any throttling. But the problem is that with Kinesis, the limits are per second. So you have 1 megabyte per second, 1,000 records per second. But the CloudWatch metrics are at the very best per minute aggregates. So you never see a second-by-second picture with CloudWatch metrics. And it's very important. You only see the aggregate. You don't know what is really happening there second to second. So for example, let's say you have a stream with one shard. So you can easily accommodate, 60,000 records per minute. And then you look at the CloudWatch and it says, oh, no worries, you only have 2,000 records that you're writing per minute. And you're thinking, yeah, I'm completely fine, no throttling can happen. But throttling can actually happen because you don't know how those records are arriving to the stream second to second. They might be bursts, there might be some delays that cause spikes in traffic and things like that. So you never know, bottom line. And only looking at the amount of incoming data will never tell you the entire picture. So you always have to check the metrics that tell you about failure. Those are the best ones anyway. So in case of Kinesis, there are 2 metrics that will tell you about throttling, so you need to keep an eye on those. So after digging deep into how the records are being written to the stream and what's happening there, we figured out that it actually boils down to 3 pretty simple principles. First of all, have proper error handling for partial failures. So proper backoffs, proper limits. Don't bring your system down while trying to fix it. Then you need to configure appropriate retry and timeout settings for your SDKs. Don't ever go with the defaults. Defaults are evil. They can break your system. Please configure them. And well, the last one, monitor more detailed metrics, which is kind of obvious. But I mean here, of course, you have to monitor different metrics that tell you about the well-being of your stream, but also you may want to implement your own custom metric that you will be meeting when your custom retries for the partial failures don't go through. And in that way, you will have a more wholesome picture of what is happening in your stream. And those basic principles will give you a pretty reliable Kinesis producer. All right, so we were talking about reading from the stream, writing to the stream. How about reading from the stream now? So let's finally get back to what was happening to our Lambda. I know I kind of left you hanging there. Let's see what happens with Lambda in general when it is used with the Kinesis stream as a consumer. So as I showed you in the beginning, it comes with a bunch of benefits, scalability. It takes care of a lot of heavy lifting behind the scenes on your behalf. You don't have to worry about things like batching and keeping track of all open shards, or keeping track of where in the shard it is reading. It's all Lambda's responsibility. And last but not the least, it has very extensive error handling possibilities. And Lambda service itself consists of many different components, but the one that is of the most interest for us in this story is called event source mapping. And you recognize it from this unicorn icon, which is not an official icon, but that's the one that I'm using. So when attaching a Lambda function to your stream, you are in fact attaching an event source mapping to that stream. And event source mapping is reading the records from the stream and then passing them on to your Lambda function. And it is also used in other service integrations like SQS, DynamoDB streams. The ones that are using batching, they always use event source mapping. If there's no event source mapping, there cannot be batching, like with direct service integrations with Lambda. So with the help of event source mapping, each invocation of your Lambda function will get a batch of records. And you will configure, or you can configure how big or small that batch is. But also an important thing to understand is that every Lambda invocation will only get one event, and that one event will contain a batch of records. So Lambda will get that batch of records, it will process it, it will be done with it, and then event source mapping will pick another batch from the stream and give it to a new Lambda invocation. So one Lambda invocation for one event and one batch always. And the other important thing to know is that batches are picked from the stream in parallel. So this means that you are going to have as many concurrent Lambda invocations reading from your stream at all times as you have shards in your stream. And you can actually throw even more Lambdas at each shard if you want to increase the processing speed or processing power. So you can actually have up to 10 Lambda functions using parallelization factor that will be reading from each shard in your stream. So like in this picture, instead of just one Lambda feeding from one shard, you can have up to 10 Lambdas. And here it's very important to watch out for Lambda concurrency limit. And you probably all know that by default, Lambda can have 1,000 concurrent Lambda invocations in one account, one region by default. And it is a soft limit. You can change it, but still there is going to be some limit. And with Kinesis, for example, you have a stream with 100 shards, and then you have a parallelization factor set to 10. And here you have already 1,000 Lambda functions that are just reading from your stream at all times. Which means that if there is another Lambda function somewhere in your account, in your region, which probably doesn't even know anything about the existence of the entire Kinesis, it might fail, it might get throttled because there is no more Lambdas left for that, or Lambda invocations left for that. So it's a limit that has a huge blast radius, and you need to be very careful about that. And with Kinesis in particular, it's really, really easy to overscale Lambda. So always pay close attention to the Lambda concurrency limit. So I told you in the beginning that we were seeing some really seriously weird behavior from our Lambda function, or Lambda. So what was happening there? So by default, event source mapping gets batches of records, and it gives them to your Lambda function, and your Lambda function tries to process them the way it can. But what happens if there is an error in that processing when Lambda functions try to process the batch? So for example, there was some bad corrupt record in that batch, and you forgot to add some error handling there, some try catch, and your Lambda just throws an error. What happens next? And the good thing is that event source mapping will take care of it for you, but once again, you need to know how exactly and what are the defaults, because we know defaults are dangerous. So by default, your Lambda function will try to reprocess a batch of records over and over and over again until it succeeds, or until the data in the batch expires. And you remember that the data in Kinesis stays for at least 24 hours. So with a bad batch or a bad record, Lambda will be retrying for 24 hours, over and over and over and over again. And you will get a lot of useless Lambda invocations, which is not nice. Okay, so what if it's a week? Or what if it's a year? Doesn't sound too good. And those useless retries will actually have another problem. They will probably cause a lot of reprocessing of the same records. So you will be processing same records over and over again, because from the perspective of event source mapping, the batches are actually atomic. The batch operation is actually atomic. It's kind of the contrast with writing records to the stream where it is not atomic. Here, either the entire batch fails or entire batch succeeds, which means that if there is one failing record in the batch, entire batch fails. So in this scenario, entire batch fails, and then it's picked up again by the event source mapping, and it tries to reprocess it again. So if you have already managed to process records 1, 2, 3 here, and then record 4 is the bad one, it throws an error, batch returns to the stream, it gets back to Lambda, and 1, 2, 3 records are processed over again. And that goes on and on and on. So obviously not too good. But bad things don't really stop there. Because while Lambda keeps retrying that one bad, unfortunate batch with this one bad record, no other batches are being read from that shard. None. So it stops. And all the other all the other shards go on with their lives. They continue processing, but that one shard is completely stuck with the retry attempts. And that's why this one bad record is often referred to as a poison pill, because just one record poisoned the entire shard. So, and after the data finally expires, the entire batch is discarded from your shard, probably with a lot of valuable unprocessed data that came with it. But the problem is, even if Lambda can at this point start to continue with processing the shard is probably filled with records that were written around the same time. So they expire around the same time. So you may end up in a situation where your Lambda just doesn't have a chance to process those records. They will keep expiring before it has a chance to read them from your shard or from your stream. So you will continue just losing and losing and losing your data. Thank you for that wonderful sound. And just because you had one bad record in your batch. So, because of one bad record, you have probably lost a lot of your valuable data. And unfortunately, that's exactly the behavior that we were observing. We saw the prolonged bursts of Lambda retries and these fruitful or fruitless Lambda invocations, and plenty of duplicate records, a lot of extra latency in our near real-time application because, come on, 24 hours of retries. And of course, the costs were going up with all these unnecessary Lambda invocations. And all of this in a nutshell because we went with the defaults. That's all. And once again, it brings me back to Gregor's quote, retries bring a lot of systems down. So the good news is here, it's pretty simple to avoid all of the situations. And guess who is going to be helping us? It's again the event source mapping unicorn. It provides a lot of knobs that you can tweak when it comes to error handling. And you can set things like maximum retry attempts, which you should always do. And also you can set maximum record age. And you can notice that the defaults are actually -1, which means no limits. Yay. There's a more exotic option of bisecting the batches, which means that you will recursively split the batches and try to send separate parts separately, but that will probably cause a lot of reprocessing of the same records over again. So a better option is actually a so-called partial success, where you can tell explicitly to the event source mapping which exact records have failed in that batch. So instead of just failing the entire batch, you say, hey, this was the record. So like, here, you can tell to event source mapping that, hey, don't process records 1 through 3 anymore. They are fine. Just start with the record 4. And that will already eliminate a lot of problems for you. Finally, if all else fails, you should always use the Lambda on failure destinations, which come out of the box. You don't have to write too much code for it. So you can send the failed records to either SQS and SNS, so you can process them later if you need to. And of course, you can use all these knobs in any combination that you want. And finally, one last very useful feature that event source mapping provides, and actually one of my favorite releases lately, because it can potentially save you quite some Lambda invocations, and if you're lucky, it can even eliminate some poison pill scenarios for you. And is the event filtering that allows you to only concentrate on the events that you're interested in. So this means that the event source mapping can actually filter the incoming data and only send the data that your particular Lambda is interested in to that Lambda function. So you will obviously save on Lambda invocations, you will save costs, lower carbon footprint. Also, less records means there is less opportunity for something bad to happen, so that's kind of a win-win. And also it's completely free. It comes with the event source mapping out of the box, no extra compute needed, so it's a very neat feature that I would really recommend you to use if you are not yet. And it's actually very easy to use. It's just JSON-based filtering criteria. And you can filter either on the payload or on the metadata, things like a partition key. So it's the exact same syntax as the event bridge has. So if you're familiar with that, it will be really easy to start using. So after digging deep, we again came up surprisingly with just a few points that composite the reliable Lambda for Kinesis, or consumer for Kinesis. So first, adjust the processing speed of your Lambda by adjusting batch size and parallelization factor. Sorry, so many abbreviations. Parallelization factor. So if you have a high throughput speed, you probably want to increase the processing speed by adding some extra Lambdas to it, so increase the parallelization factor. If you have a low throughput stream, you probably want a bigger window, a batch window before Lambda is invoked, so you will avoid unnecessarily Lambda invocations. As always, spend a lot of time figuring out how error handling works and configure proper error handling, in this case with event source mapping. It provides you a lot of options. Don't go with the defaults. Finally, save the planet, only consume what you need, filter out the records that you are not interested in, and that will help you to create a reliable Kinesis stream consumer. Okay, so we are almost at the end of our road, and just a few final thoughts here. So first of all, of course, I didn't have time to go into so many things here. I mean, I used to teach a 4-hour-long course on the subject, and I always ran out of time. So I wrote really, really long blog posts, 2 of them. user manuals, you can call them, about the subject. So if you are feeling at all inclined, please go read it. Also, an article that I'm always recommending is the one from Amazon Builders Library about timeouts, retries, and jitter. I really recommend you to read that one. In general, Amazon Builders Library, one of the best releases AWS has ever made. Finally, in the ideal world, you would just connect the pieces and everything would just work as magic. But even in that case, I would argue that it's valuable to understand how services work and interact with each other and how they fail. And while we are not in the ideal world yet, the story like this one, the one that I told you, can actually discourage some from using some certain services or certain architectures, which in my opinion would be a pity because we would do ourselves a disservice. Because basically the story like the one I told you is just an ordinary consequence of having a real world big scale application instead of just simplistic hello world scenario. So considerations that I told here apply to distributed systems in general, so things like partial failures, retries, backoffs, they are all common considerations that you always need to keep in mind. And in any case, whichever services you use, you always have to make a trade-off there. So there are multiple services that will probably work, but none of them will be perfect and will fit all the possible aspects that you have. Things just don't work like that. And we need to be pragmatic when we pick the services that we use, and we need to base that choice based on the architectural aspects that we want to build. And it's also fairly easy to dismiss some services or some architectures when things don't really work exactly as you expect, instead of just kind of trying to figure out what's going on there. And in case of Kinesis, I have this feeling that it's one of those more misunderstood services that people might have troubles with at first. But despite my own rants about it being serverless or not being serverless in the beginning, the bottom line is still it's one of the most reliable and one of the most scalable services with tons of integration within AWS infrastructure. So I would argue that we would be selling ourselves short if we wouldn't have it in our service toolbox. Lastly, don't be afraid of failure. Embrace the failure. Failures are good. Each failure is an opportunity to do things better the next time. And if we wouldn't embrace failures as kids, we would never learn how to walk or do any other fun stuff. But somehow along the way, we learn to take failures as something negative. Well, in fact, it can be one of the best things that happen to us. Because as Dr. Werner Vogels likes to say, everything fails all the time. And that's just the reality of things. I mean, either in life in general or with AWS services in particular. I would argue that the best thing we can do is just to stay calm and be prepared when that failure happens. And that's all for today. Thank you all so very much. And it was fun. I hope it was fun for you too. Thank you.